This video tutorial explains derivative of constant function in three ways: by simple differentiation, by definition, and through graph. Let us take a function f of x is equal to c. Here c represents any constant. In mathematics, constant may be any number or a term whose value is fixed or can't change. And the derivative of any constant is 0. Here d by dx mean you are differentiating c with respect to x. For example, if we want to differentiate any number 4, so the derivative of 4 is 0 because 4 is constant. Now let us take some negative number minus 7 and the derivative of minus 7 is 0. Let us take another example. If we have a number 8899 and the derivative of that number is again 0 because it's a constant number. Now let us take a number which has fixed value in mathematics, likewise pi. Pi is a number which has fixed value in mathematics. So the derivative of pi is 0. Now let us take any alphabet A. A is a constant and its derivative is again 0. Let us take any mathematical constant like E. E is a number which value in mathematics is approximately equal to 2.71 and E has a fixed value number, so again the derivative of E is 0. Now I explain the example of derivative of constant function by definition method. Let's see the example of derivative. If we have f of x is equal to 3, let's show that f prime of x is equal to 0. We solve this question by considering definition of derivative. We know that d by dx f of x is equal to limit h approaches to 0 f of x plus h minus f of x divided by h by definition. Here f of x is equal to 8. So what is f of x plus h? For this we need to replace x with x plus h in f of x. So here there is no x. So f of x plus h is equal to 8. By substituting these values in formula, we get d by dx f of x is equal to limit h approaches to 0, 8 minus 8 by h. So which is equal to limit h approaches to 0, 0 by h. 0 divided by something is equal to 0. So here the whole thing is 0. It's mean the derivative of any constant is 0. Now we show the derivative of constant function by graphical representation. Here you put a close look toward the graph of the function f of x is equal to 2. Geometrically, we represent here a graph. Derivative is basically a slope of tangent line. In my function, we see the slope of a tangent line, which is the derivative, is actually a rise over a run. So here there is no rise, no run because it's a horizontal line. So we say that in this case the slope is 0. If you like this video, then don't forget to hit the subscribe button. Thank you.